It's so embarrassing. A few weeks ago, I recorded a video and I called it the Phantom LED Glow. Anyways, what I did in that video was we had a circuit. It was an LED driver circuit. A single LED was being driven, and I had these three switches. Those three switches, different combinations of those switches would give 8 different levels of intensity of that LED, right? So if no switches were pressed, it would be lowest intensity, or it should have been 0. And with all switches down, it would have been the brightest possible. But what I discovered in that video was that when I released all 3 switches, even though we should have an LED that was completely off, we found that it had a slight glow. And I called it the Phantom LED Glow. Here, take a look at this clip. Look at this clip. Take a look at this. Look at that smug face that guy's got on. Oh, it's so embarrassing. He had this, I had this smug face on, thinking, oh, look at that. I solved the problem. I resolved this whole mystery LED glow. I didn't solve the problem. Who did I think I was kidding? All I did is I stuck my head in the sand and I ignored the fact that there was a problem. What I should have been doing is asking, why am I getting this glow? I need to measure this glow because it's going to affect the rest of my circuit. But no, I didn't do that. I ignored it. Oh, so embarrassing. And I just went on like, oh, look at that. I solved the problem. Anyways, I said, no, I'm going to have to look at this because I need to understand what is going on over there. So I had to pull out the circuit again. Here it is. This is the circuit I had to pull out. And when I started looking at the circuit, I started thinking to myself, oh, if I'm going to figure out what's happening with this glowing LED, I'm going to need to simplify this. So I took the circuit that I have here and I said, well, look, this is important, right? I have all my LEDs that I need to glow. Over here is this feedback mechanism that's going to make sure that these LEDs don't explode when I turn them on. And then over here, I have those 3 switches that's going to help us adjust the intensity of those LEDs. But I had all this other stuff, including these diodes over here, a couple of extra resistors. We had these other MOSFETs and this resistor. All of that was added to eliminate this phantom glow. So I said, I got to get rid of it. So I pulled it out. I basically removed that and I simplified the circuit to this. Same circuit with all the extra stuff that we put in to remove the glow, removed. So what do we have now? We got the LEDs, we have our 3 switches that control the intensity of those LEDs, and we have our feedback mechanisms that make sure that LED doesn't explode, or those LEDs don't explode. So I got to tell you, I mean, trying to understand how this feedback mechanism works, it made my head hurt, as I alluded to in another video that I did. So I knew right away I won't be able to dive too deep into this, but just looking at this schematic the way it is, it kind of is obvious how many current paths or possible places can the energy flow in our circuit. It's coming from the positive. It's going to go through the LEDs. And after it goes through the LEDs, it's going to either go through this branch over here, or it's going to go through one of these 3 branches, or all of the above, or a combination of. So if I release these 3 switches and make sure they are not connected, there still is a path of current to follow, right? That path is down through the LEDs and through this little piece right here. This is the base current of this transistor. That path is it's going to be there. And that was what was contributing to this phantom glow that I had before. So today, instead of ignoring it, let's measure it. Let me bring the circuit back and let's see what's going on over there. All right, here's our circuit, which is pretty much the same circuit we had before. And if I push some of these lights, or push the buttons, you'll see the lights light up as expected, right? This is the lowest intensity, and if I push all 3, I'll get the highest intensity. But see, there's no illumination. Right now, the LEDs are off, which is what we expected. Well, that's because the extra stuff in the circuit that turns it off is still there. All I gotta do is take this little blue wire over here and pull that out, and I'll disconnect all the extra stuff in the circuit. So that's what I'm gonna do right now. I'm going to pull that out. And look at that. We have a glow. This is that phantom LED glow. I want to measure it. So let me get my meter here and I can measure this. Oh, by the way, I got a funny, you know what? While I'm on the realm of embarrassing stories, take a look at this meter. I think this meter is older than me. It is an ancient meter. Anyways, I've always, growing up through school, we had these meters where if you wanted to measure current, you would use the other port. Notice how this meter has 2 ports or 3 ports. It has a common port. This is where you measure voltage, and it has another one where you measure current. And the meters that I used in school, if you're measuring voltage, you'd leave it here. If you're measuring current, you'd put it here. So when I started using this ancient meter at home, I started doing the same thing. I put it, when I measure current, I put it in here. And I would always wonder, this thing doesn't work. It's not measuring anything if I'm trying to measure something in the milliamp range. Another embarrassing situation. I didn't stop to look at this meter closely and figure out that, well, for currents that are less than, well, I guess in this case, less than 2 amps, I'm supposed to be using the same port. So I feel like for years, I've been complaining that my meter wasn't working, and I was about to go out and buy one of those fancy meters when I really didn't need to. This meter's just fine. I was being an idiot and not using the right ports. Okay. Anyways, let me plug this in, and we're going to see what kind of current we're actually getting here. So let me use this. I'll use my prongs here. There you go. After the struggle, I finally got a number. The phantom current going through these LEDs with all the switches off is 6.84 milliamps. That's actually quite a lot. What does this mean? I mean, think about this practically, right? If I don't push any buttons, meaning I'm expecting the LEDs to be off, I would expect that to be off. But it also means something else. It also means that I have no way of making the intensity any lower than this other than off. I can turn it off by connecting the rest of that, the off current or the off circuit, but I can't make it any dimmer. This is the minimum dimness or the minimum intensity of my circuit. And it's actually quite bright. What if I want to make this a little bit dimmer? Well, this is where we had to bring back our circuit diagram and look at it a little bit more carefully. Let me bring it back. So when I looked at this more carefully, I thought, okay, how can I reduce the amount of current going through this branch of this transistor? I have no way of doing it because all of these switches are off. I can't control any resistance here. There's nothing for me to do, except there was. I had to think back from the school days. This transistor, the base current or the current that's causing my phantom glowing, it is related to the collector current. In other words, it's related to the current coming through this way. So I don't exactly know how it's related. Back in the school days, we learned about this stuff called, beta and all sorts of stuff I'm not going to get into. But there is a relationship between the amount of current flowing through here and the amount of current flowing through here. So on a whim, I thought, well, if I reduce the amount of current flowing through here, would the amount of current flowing through here get changed as well? I think it might. And I have the ability to reduce the amount of current through here. It's through this resistor. If you remember, the circuit we have right now, I have a 1 kilo ohm resistor over here. So I thought, let's increase it. Let's see what happens. Sure enough, it worked. And look at the difference it made. Let me bring back the circuit. All right, here we are operating with the 1 kilo ohm resistor, which is right here. This is the offending resistor. Let me change that. I actually happen to have if I can find it in my pile over here, which I very unintelligibly made earlier. I have another resistor here. I have a 100 kilo ohm resistor. So this is 100 times higher than this. Truth be told, I actually experimented with a few in between, but I settled on this. So let's watch what happens when I change it. So I'm just going to pop this out. We should see everything turn off, and I'll put this in. Look at that. The LEDs right away are a lot dimmer than they were before. And look at the amount of current. I actually have to pop this up a little bit. 2 notches. I can move this up 2 notches and see that we have a current now of 87 microamps. This, I think, we can deal with very well. 87 microamps through these LEDs when everything is off. This now means that my minimum intensity for my lighting system is this. I'm happy with that. So, truth be told, I did experiment with this value. So I actually put 10 kilo ohm, which did bring it down appropriately. I even went higher. I tested a 200 kilo ohm and a 250 kilo ohm, even a 510 kilo ohm. And to be honest, it did reduce it any further, but we're so down in the range that I'm actually okay with this. I felt like anything more and I'd get diminishing returns, because right now, 3 switches gives us 8 intensity levels. And the minimum intensity level for a 350 milliamp circuit would be like 50 milliamps, right? Based on our circuit right now, which is, a lot higher than the 6 milliamps that we're getting in the 1 kilo ohm, but it's also way higher than this. Even if we had 1,000 different levels, 1,000 intensity levels for this lamp or this lighting system, the minimum intensity on 1,000 levels would be in the realm of what, 0.3 or 350 microohms or microamps. Well, we're still well under that. We're at, just under 100. So I'm okay with that. I think we can just leave it as is. I'm comfortable with this. When I was doing this discovery, though, or when I was doing this investigation, I discovered something else about our circuit. And that is the circuit. I got to bring back the circuit diagram again. Hang on a sec, I'll bring that back. I think I need to invest in another camera. That way I can have my circuits, diagrams, and the circuit in front of us. Okay, note for sometime in the future. All right, but look at this. So I'm bringing my circuit back. And what we were going to do is I wanted to, the other thing that I discovered, when I change the current through this base resistor or through this base branch of the transistor, that helps us reduce our phantom glow. So this is a good thing, right? We want to reduce that phantom glow through the LEDs by adjusting the current. That had another side effect, though. I discovered that the voltage across these 2 points also changes depending on the current through them. And so why is that important? It's important because the voltage across these 2 terminals is going to be the same voltage across these resistors. And this is really important is because these resistors is what's allowing us to control the intensity. So if I want accurate control of my light, well, I need to be able to control these resistors quite accurately. And so the fact that voltage changes depending on the current, that just proves that physics isn't very nice. It does not make things easy for us, right? It means that for a low current or a low intensity, I have a certain voltage that I can play with in order to get the right amount of current through here. But as my intensity goes up, my current is going up and the voltage is going to change, which makes the calculation so much more difficult. Anyways, I am not going to get into the details of how I figured out what resistances I should use on this video. Because I figured, I was thinking about this and I thought, there are times when you may want to get into the weeds. There are times when you want to roll up your sleeves and get deep into the details. But there are also times when you really don't want to get that detailed and you just kind of want to lay back and you're like, just give me the answers, Arif. Just give me the summary. So I want to respect your wishes, all right? If you want to get into the details, I'm going to make another video and I'll link it in the description so you can actually roll up your sleeves and get into the hairy arms session of figuring out how I got to the final results that I did. But since we're not on that video, I'm just going to give you the numbers, okay? So what I resulted in, I found out that the voltage change from the lowest to the highest current, it wasn't much. At the minimum, we had about 620 millivolts, and at the peak, so at the highest current, 350 milliamps, we had about 660 millivolts. So it wasn't much, but it was enough to make an impact. And based on the calculations that, again, if you want to, go take a look at the other video that I will link to you. We're going to call it the hairy arms video because we're going to roll up our sleeves. I discovered that this resistor, for this all to work well, I think I wrote it down here. Where did I write it? Oh yeah, right here. So this resistor I found out it's got to be about 11.5 ohms. This one was supposed to be 5 ohms, and this one was supposed to be 2 ohms. Or the other way around, as long as they're in order. So 2 could start here, 11.5 could end there. Anyways, with these calculations, according to the mathematics, I'm supposed to be able to get close to 350 milliamps. That's maximum intensity with all those switches pressed. And with none of those switches pressed, well, I'm going to get supposed to be 0 or my 87 microamp low intensity. Well, I put those resistors into the circuit. Let me yet again shuffle this around so I can bring it back. All right, so I've brought back the circuit and I've adjusted my meter. I wanted to adjust it for the 2 amp range so we can see the larger numbers that are going to be going. And looking at my resistors now, I actually can see that I put the numbers in backwards. So these ones over here, these 2 resistors together are what's making the 11.5 ohms. These 2 resistors over here make 5 ohms, and these 2 resistors actually in series are making the 2 ohm resistance. So I wrote it down on the schematic backwards, but you get the idea. So we have our 3 switches. Let's see what kind of currents we get. So with the lowest intensity, we can see that we have just about 50 milliamps going through. Let's increase that. There's 100 or 99, close to 100. If we took both, the next step should be 150. We're at 148. Next, we're at 193. This should be about 200. Next, there's 250. The next level is 300, but we're at 287. And finally, maximum intensity, 332 milliamps. We're not quite getting the 350. Perhaps, well, look at my circuit. It's not really a tight circuit. It's all sorts of leads and resistances and extra stuff. Plus, I'm using a breadboard here. So I think if I actually wanted to get 350 milliamps out of this, I'd have to take this circuit and put it onto a proper prototype board, which means soldering and all sorts of fun stuff, which we will get to, just not today. So I think for now, this is probably the best I'm going to do. We can actually get close to 350, close to our maximum intensity. And we did not ignore our phantom current. But now that I'm comfortable with this phantom current, I think we can just plug this blue lead back in and make it go away and stick our head right back into the sand.